Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at arrays, but this time at scanning for data within arrays. We have completed a number of videos on the subject of arrays and how you can access and manipulate them from within PowerBasic, both in the Windows and console compilers. Today we're going to revisit one specific part of handling arrays, and that is scanning the data within them. The inbuilt array scan command in PowerBasic is very powerful and gives you the ability to find information that's held within an array very easily. So first of all, we're going to look at a one-dimensional array. And we're specifically going to be looking for some target data. So we will create a local variable and populate it with the target data we are seeking. And there is our local variable, target, and we've populated it with a date, giving year, month, and day. We'll now create a function to allow us to scan a one-dimensional array for that target data. So here is the call to our new function, do1dscan, taking a single parameter, which is the target data we are seeking. So let's now go and create this new function. So here is the skeleton of our new function, taking its single parameter. We have declared a local array called strdata. This will contain the data that we wish to search. So our first task is to prepare this one-dimensional array with some data. So we'll create a function whose purpose is to populate that array. So before we go any further in this function, we will create this population function. And here is that function, taking its single parameter, which is a reference to the array we have dimensioned in the previous function. So we're redimensioning this array as having elements between 1 and 5. And we're using the very useful arrayAssign command to specify the array we wish to populate and give it a list of values for these 5 elements. So this function will put this data into our target array. Now we've populated that, we can attempt to scan that array for the data we're looking for. So back to the previous function. We're putting a message out to our log to say we are scanning for the target. In this case, our target is going to be the 2nd of November 2025, which should be the second element in the array. So in order to search out that element, we're going to create a local variable called element. This will contain the element number of what we've found. So we're going to create a new function whose job it will be to scan this one-dimensional array. It's taking 2 parameters, the reference of the array and the target we're looking for. So here is the skeleton of our new scan1d array, taking its 2 parameters. This will be a very short function, as we're going to use the arrayscan command to find the information we need. So first of all, we will create a local variable called element. This will contain the element we found if we have indeed found the target. And here is the arrayscan command. It takes a number of parameters. The first is the name of the array we wish to search. The next command in this case is a collate command. Admittedly, we are searching for what technically is a date, but it's handled like a string. So we're using collate uppercase to make sure that whatever we're comparing is case independent. It compares the target as uppercase against the target uppercase in the array. And should we find something, the element within that array will be deposited into our element variable. So all we need to do to complete this function is to return that value. So this will populate our variable in the calling function. So now to make sure that we found the correct one, I'll want to display the entire array. So we'll do a simple for next loop to step through each element of the array and display it on the log. So we're creating a local variable to allow us to step through each element of the array, and we're using the lbound command to say I want to go from the lowest bounding of the array to the upper bounding of the array. This way, we're not assuming that the array starts at the 0 element or the 1 element, or for that matter, any other element. And we're printing out the element number and the data which is held within the array itself. And the final line of code within this function is to print a message out to our log to say that the element found in the array was and the element number. So that code should compile quite happily now, which it does, so we can try running the code. And there is our output on the screen. We're scanning for the 2nd of November 2025. We're printing out the contents of our one-dimensional array, which we can see that date is element number 2, and our report output from the scan to say the element found in the one-dimensional array is element number 2, which it is indeed. So we have successfully scanned our one-dimensional array for a particular piece of data. That works very well for single-dimension arrays. But what happens if you have a multi-dimensional array, 2-dimensional or greater? How can we search specific data out in that using our array scan command? Let's go back to our PB main function and we will create some more functions to allow us to scan 2-dimensional arrays. So we're going to create a new section of code to allow us to scan more dimensions. So here is the section of code that's going to allow us to do a scan of a 2-dimensional array. As we've done before, we're calling a function to allow us to do a scan. We're passing it this time 2 parameters, not only the target, but also the column number that we are interested in. We're still looking for the same date, but we're looking for column number 2. So let's create that function. As we did before, we're dimensioning a local array as string. And we're going to call a function to prepare and populate that array. So here is the skeleton of our new function. And this time we're doing a redem of the array for 5 by 2 elements. Effectively, this format is equivalent to this: 0 to 5 and 0 to 2. So this array is going to have a 0 element. It's quite common to use the 0 elements for column headers, and that's exactly what we're going to do in this array when we populate it. We're going to make the 0 row and the first column equal to the title account, and the 0 row and the second column equal to the word date. And we're going to make the remaining 5 rows equal to a number of values. The first column is going to be equal to an account number, starting at 1000 and going up to 1004. The second column is going to contain the date, and we're going to have dates ranging from the 1st to the 5th of November. So now that we've populated our 2-dimensional array, let's now go back to our calling function to allow us to search out from that array. So as we did before, we're putting a message out to the log to say we're scanning for this specific target. We're creating a local variable called element to contain the element we've found, if any, and we're going to call a function to do the actual scanning. In this case, passing 3 parameters: the array, the target we're looking for, and the column number we want to look in. So let's now go and create this scan 2D array. So here is the skeleton of our new function taking its 3 parameters. We're going to create a local variable called element, and we're going to use array scan. However, this time we're going to use it slightly differently to allow us to scan a specific column. And this can be done by, when specifying the array, we specify 0 for the row and the column number. In this case, we're passing in column number 2, so we search only the second column. And the remainder of the array scan command is as before. We're using collate uppercase, so it's a case-independent search, and we're putting the output value into the element variable. And as before, we're returning that element to the calling function. So our array scanning is very similar to the previous function. The only difference is we're specifying the column that is of interest to us. So in the calling function, once we have obtained the element we have searched for, we'll now want to display our two-dimensional array data on the log. So it's going to be a nested for next loop here, stepping through each row and each column to display information on the screen. This will easily display the information so we can compare what we searched out against what currently exists within the array. And as we did before, we're printing out the element that we actually found. So let's run the code now and see what we get. So there is our first scanning for the date in a one-dimensional array, and here is our second scanning of a two-dimensional array. We're again looking for the same date, the 2nd of 11, 2025. And we can see in our array the 0 element containing the headers and the number 2 element containing the date we're looking for. However, the element found in the two-dimensional array says element number 3, and we can quite clearly see that the date we're after is in element number 2. So what is actually happening here? Well, when you scan an array starting with a 0 element, the value returned from the array scan command counts 0 as the very first element, 1 as the second, and 2 as the third. So we need to take into account that this array starts at 0 rather than 1. So we can handle that quite happily in the code by testing the array. And in here, we're checking the array bounding. So the lower bound of the array for the first dimension, if that is 0 and the element number returned is greater than 0, then we can decrement the element number. This will work in this case because the element number we're using is starting at 0. If the element number was starting at some arbitrary number, say for example 1000, you would need to code this slightly differently. But if we run this code now, we will see the element found in the two-dimensional array is now returning as the value 2, which, as we can see, is the second element in our array. So we have successfully scanned a column within a two-dimensional array. So let's assume we want to look in another column now, but still in this two-dimensional array. So let's go back to our PB main function. So we're going to set our column number to be column number 1, and our target in this case is going to be 1002. So we can see from this that we're going to be searching the account number column. And we can use exactly the same scan function to look for our target. So let's run that again. And we'll see from our third scan, we're scanning for 1002, and we're finding it in element number 3. And there it is in element number 3. So we can use that scanning function to scan any column we wish. So what will we get if we attempt to look for something that doesn't exist? So let's put in some more code to search for a date that doesn't exist in our two-dimensional array. So this time we're looking for the 2nd of December 2025. And we know from when we set up this two-dimensional array that that date does not exist. So if we run the code now, we'll see from our scan here, there is our array, there is the date we're looking for, and the element found is 0. In this case, 0 would mean it did not find the date we're after. So in summary, what we've achieved today is we have created some generic routines to allow us to search through one- and two-dimensional arrays. In searching a two-dimensional array, we can specify the column number which is of interest to us. And as it is quite common to store data within your applications in two-dimensional arrays, you should find this very useful. However, that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.